Welcome to another video. In this video, I'm going to teach you about the right angle triangle. Now, looking at the right angle triangle that we have, we've got different sides of the right angle triangle. We've got the hypotenuse, we've got the base and the altitude. How then do you identify each side? So in our right angle triangle, the hypotenuse is always the side that is opposite from the right angle. Our right angle is here, hence the side that is opposite from this angle is our hypotenuse. So for example, if we're given a different diagram here, and this is our right angle, that means that our hypotenuse is the side that is opposite from this angle. So hence this is our hypotenuse. Now, the altitude and the base can be interchanged, but these two are the sides that are away from the hypotenuse. So hence in our case here, this is our altitude and this is our base. And our altitude is always perpendicular to the base, which forms the 90 degrees or the right angle for this triangle. Now, what does the Pythagoras theorem state? The Pythagoras theorem states that the square of the length of the hypotenuse is equal to the square of the altitude and the square of the base added together. How or what does that mean? It means that the square of the length of the hypotenuse, which is c squared, is equal to our altitude, which is a squared, plus our base, which is b squared. So this is a formula you're going to use every time you want to find a side given the two sides. Either you're given the altitude and the base, you're taught to find the hypotenuse, or you're given the base and the hypotenuse, you're taught to find the altitude. So whichever variations you're given, always note that c squared, which is your hypotenuse, is equal to a squared plus b squared. So here is an application of the Pythagoras theorem. So I've been given a diagram which is showing the demarcation of the garden. Now we'll note that here we've got AED, which gives us our right angle triangle, and then there's also this shape right here. So in general, this is a polygon. Now, this polygon has different sides. The first question they're telling us is to find AD. Find AD. The data is that the distance AB is equal to the distance BC is equal to the distance CD, which is equal to the distance AD. Now, this whole thing where all sides are equal, this simply is a square. Now, AE is 12 meters, ED is 5 meters, and the angle ABC, so this angle right here is equal to BCD, is equal to this angle, which is equal to DAE. This is 90 degrees, meaning this is also 90 degrees, and this is also 90 degrees. Now, how do you find AD? So what we're going to do is that we're going to cut this shape here, right here, and we're going to find it separately. So this is our D, this is our E, and this is our A. This is our right angle right here. Now, how do we find AD? This is 5 meters, this is 12 meters. How do we find AD? Remember, the first thing you're supposed to do is to identify the sides. So we're identifying the sides. Our AD is simply our hypotenuse. Why? Because it is the side that is opposite from the angle, which is our right angle. This is AE and ED. ED is our base, AE is our altitude. Now, in our case here, we know that AD, according to the theorem of the Pythagoras theorem, AD, the square of the hypotenuse, is equal to the square of AE and ED added. So this is equal to AE squared plus ED squared. So this is equal to AE is 12 meters squared plus ED is 5 meters squared. Hence our AD goes down here. So this is equal to AD squared is equal to 12 meters squared is 144 meters squared plus this is 25 meters squared. Now, if you've noticed, we've squared the 12 and the m, so this will be 144 meters squared. Note that, and always pay attention to the units that you're given. AD, in our case here, squared will be equal to 144 plus 25 is 169 meters squared. You keep the meter squared because they have the same units. Then you find the square root of this side and that side. So I'll bring it right here. So this will be AD squared is equal to 169 meter squared. We find the square root of that, the square root of that. So this will be AD, since this will cancel, and that is equal to the square root of 169 times the square root of m squared. This is the same as this. I just want to simplify it so that you see how this is going to cancel out. Hence, AD is equal to 13 meters. So this will cancel out, remain with meters because it's a distance and not an area. So this is our distance AD. Hence, AD is equal to 13 meters. Now, the next question says, find the perimeter of the garden. So, finding the perimeter of the garden. Now, what is the perimeter? Perimeter is the distance or the total distance around the given shape, not inside, around the given shape. So, the distance from here to here to here to here to here and to here. Now, knowing that this is 13 meters, and we've been told that AB is equal to BC is equal to CD, it's equal to AD, meaning this is 13 meters, 13 meters, 13 meters. Hence, this is 13 meters, 13 meters, 13 meters. Perimeter. So, perimeter, this is our second question, is equal to, we start from here to here to here to here, going round. So, this will be AE plus ED plus DC plus CB plus BA. And this is equal to AE is 12 meters plus ED is 5 meters plus DC is 13 meters plus CB is 13 meters plus BA is 13 meters. So this is around the shape that we've been given. So this will be equal to 12 plus 5 plus 13 plus 13 plus 13 is equal to 56 meters.